All right, we are on lesson 8-1 for Algebra 2. Today's date is Tuesday, April 16th, 4/16, 2019. All right, so our standard that we're working on today is to understand logarithms and understand that logarithms are the inverse of exponents. Our whole last unit was exponents. Now we're going backwards. All right, so I'm going to introduce this new function. I'm going to call it the what power function. So this thing right here, I'm reading that as 2 to what power is 8. And I'm going to abbreviate that. 2 to WP what power, 2 to what power is 8. And I forgot to pass out cards. Who wants to do that? You're closest. All right, 2 to what power is 8? Fiona? Yes, it is 3. 2 to the third power is 8. So we're getting some experience with this what power function. So let me come back over here and come back to Classcraft, come back to Algebra 2. And people that are gone, Eva is gone, Stego, Andrea. All right, and then Fiona just got her participation. All right, so who can read this problem and answer that problem? I'm looking at example 1. How do I read that? Because that's part of the lesson. How do I read that and what is the answer? All right. What are we doing? Go for it, Teflon.
What power?
What power does 3 need to be raised to? Exactly, yeah. So what power does 3 need to be raised to get to 27? So your answer is 3, and that's right. Because if I go on my calculator and say 3 to the power of 3, it does tell me that that is indeed equal to 27. So 3 to what power is 27? 3 to the third power is 27. They just both happen to be 3. Just kind of a random coincidence. All right, so thank you, Teflon. Next one. Who can read it? Who can answer it? Go for it, James. Read it.
10 to what power is 10,000?
Yeah, there it is. 10 to what power is 10,000?
100.
Ooh, really close. So whenever I'm doing, I can do a few examples off here to the side to help you out. So if I do 10 to the power of 2, that's 1 with 2 zeros. If I do 10 to the power of 6, that would be 1 with 1, 2, 3, 4, 5, 6 zeros. So how many zeros do you count?
4.
All right, so 10 to what power is 10,000?
4.
There it is, 4. All right, writing this out. All right, James is now in. I have his card. No, try to make it in here. I don't want to get my face hit by a card. All right, let's do a few rules for review. X to the power of 0. Anything to the power of 0 is what?
Anything to the power of 0 is 1.
There it is. Thank you, James. Anything to the power of 0 is 1. Write it down in your notes. Ooh, how do I get rid of a negative exponent? If I have x to the negative a, how do I get rid of a negative exponent? So another negative would make it go away, but we can't really add just another negative without changing it. How can I change this property? By the way, this is x over 1 to the power of negative a, if that is going to help anyone. Something about flipping? All right, let's not throw cards at each other, guys. Who remembers this property? Something to do with taking the reciprocal.
Is it not like 1 over x and then to the power of a?
It is, yeah. 1 over x to the power of a. X to the power of a. So thank you, Teflon. And what about this other one? This is kind of the same rule, taking the reciprocal again. Whenever I take the reciprocal, I just change it to a negative or from a negative to a positive. Fiona?
X to the a?
It is just x to the a, exactly. What we're doing here is we're just flipping or taking the reciprocal and then making it a positive power. And again, I could do the inverse of that. I could say if I had, for example, 3 to the power of negative 2, or 3 to the power of 2, I could say that is equal to 1 over 3 to the negative 2. I can go back and forth with these properties. All right, give me a fist of 5. How well are you understanding so far? The what power function, these review of rules, Chris? What are you at? Are you at a 0? Are you awake? I see you wiggling your pencil. That's as much as I got from you. All right. Thank you, guys. Let's go to example 3. I need someone to read the problem and answer the problem using those rule reviews that we just did. Go for it, James.
5 to what power is 1?
Yeah.
Is it 1?
Ooh, careful again. Teflon does have it. Did you hear, James?
0.
0. Why, James, do I have to raise that 5 to the power of 0? Which rule am I using?
Because anything to the power of 0 is 1.
Exactly, yeah. So what I could have written here is I could have done a what power does 2,359 need to be written to get to 1? The answer is still 0. What power of anything in this base to 1 will always be 0, because I can always get 1 by taking it to the power of 0. All right, I'm going to start getting a little bit trickier here now with our what power function. Example 4, who can read it and also answer it? And let me come back here and give James some XP and give Teflon some XP as well. Who can read example 4 and solve example 4? Go for it, Fiona.
7 to the what power is 1/7?
Yeah.
Is it -1?
It is indeed -1, yeah. So if this is basically saying 7 to the negative first power will give you 1/7. And that is using this rule right here. So it's saying 7 to the -1 is 1 over 7 to the 1, or 1/7. Ask me questions now, because we're just going to get more and more complex. No questions? All right. All right, it's finally time to teach you logarithms. I mean, this whole unit is logarithms. This lesson is definitely logarithms. All right, so the proper name for this what power function that I've been defining is called what? Easy XP here. What is this what power function really called?
Logarithms?
Yeah, it's called a logarithm. Thank you, James. So I'm really talking about logarithms here. So if I had this function, or this what power function, base 2 of 16, I can really write this as, and this is the key pivotal moment of today, log base 2 of 16. It's the same thing as the what power function. We call them logarithms because I don't know, maybe it's Latin or something. I don't actually know the reason we call them logarithms, but every single time I see a logarithm in the wild, I always think to myself, oh, that's a what power function. That's a what power does 2 need to be raised to get to the power of 16. So what is the answer? Log base 2 of 16 is what?
Wait, what does logarithm mean?
It's just a what power function.
Um,
Logarithm is what power. It's asking you the power. And I'll do my really big reveal at the very end when I do the definition of a logarithm. But for now, we're just going to go with it. It's called a what power function. Yeah, Fiona, 2 to what power is 16?
4.
2 to the 4th power is 16. Thank you, Fiona. All right, so how do we pronounce this? I've been saying it over and over again. How do I say this thing now?
Log.
Yep, log is the first word.
Logarithm. Base.
Base. Log base 2 of 16. We're going to be like that kindergarten class. We're all going to say it at the same time, including Chris. Ready? We're going to say log base 2 of 16. 1, 2, 3. Log base 2 of 16. Perfect. All right. So we're moving on here to example 5. I need someone to read it and someone to answer it. Teflon, go for it.
Is it 3 to what power is that?
So that you're thinking about it right, because it is a what power function, but how do I pronounce it in terms of this new thing that I'm talking about? We're kind of abandoning what power, although that is in the back of our mind now. How do I pronounce this thing? It is log base 3 of 9. And what is log base 3 of 9? It is 2. Yeah, thank you, Teflon. All right. Who can read example 6 for us? And this one is a slightly trickier problem. By the way, everything from example 1 through 5 is the first homework assignment. Examples 6 through 9 are the second homework assignment. There are 2 difficulty levels. All right, Fiona, go for it.
So log base 3 of 9.
Yep, that's how you say it.
-2.
There it is, -2.
Oh.
And if this is confusing for anyone, I can rewrite this. So I'm saying 3 to this blank thing is equal to 1/9. Well, I know that it needs to be a negative. A negative, if it was just a -1, that would make it 1/3. But if it was a -2, it'd be 1/3 squared. 1/3 squared is 1/9. Hopefully that helps out a few people. All right, example number 7, after I give Fiona her XP. Example number 7. Who can read it? Who can answer it? I see one hand. I'm going to wait for everyone to figure out how to do this one. It's kind of tricky still. James, go for it.
Log base of 1/3 of 27.
Yep.
Would I just say log over or
So I'm just looking for a number right here.
9?
9 is not quite right. So I'm thinking 1/3 to what power gives you 27? So 1/3, that's going to be raised. This whole thing is going to be raised to something, and that should somehow give me 27. So first of all, I need to flip it. So that means what, James? It's going to be a negative, exactly. And then now it's flipped, so now I have 3. 3 to what power is 27? 3 to what power is 27? 3. So it's, your answer all at the same time now is, oh, careful, I need to flip it also. There it is, -3. Yeah, good job so far, guys. All right, we're on the back. We're getting harder and harder and harder. All right. Oh yeah, I'm not gonna steal it from you guys. Who can read it? Who can solve it? I would consider 8 and 9 two of the hardest types of problems that you will see on the homework tonight. Example 9 is pretty darn difficult. I actually haven't seen an example 9 type problem for quite a few years. All right, Fiona, for number 8, go for it.
Log base 25 of 5.
Yep.
Is it 1/2?
It is 1/2, yeah.
Wow.
All right, so this, I guess I should have included maybe a slide or like a little section on how to do fractional exponents. But again, the problem was 25 to what power is 5? So 25 to what power, I'm trying to find the box, is 5. Well, I know that the square root of 25 is 5. How do I write the square root as a fractional exponent? Square root is really 1/2. So the power of 1/2 will give you 5. All right, specifically for example 8, give me a fist of 5 just for example 8, because that was really confusing. Chris, what do you got? For example 8. Okay. Do you have a question? I can help you understand? No? Okay. So 25 to the 1/2 is the same thing as the square root of 25. All right, so this is by far the hardest example, number 9, level 5 out of 5. How am I going to do it? I can read it for us. Log base 81 of 1/27 is, and I'm thinking in the back of my mind, what power does 81 need to be raised to in order to get to 1/27? And I think what will help us is skipping down to the definition of a logarithm. Usually this is where textbooks start. This is where our lesson is close to ending. So I need to rewrite this in exponential form. So everyone write this now. Underneath here, this is called the logarithmic form. I think it's logarithmic. It might have an A in there. Maybe I should do a spell check. Let's Google it. Logarithmic. Okay, it does have an A in there. Sorry about that. Logarithmic. Logarithmic form. And then I want to convert this to exponential form. All right, who can do that still using our what power function? I have to rewrite it. If our answer was x, how do I ask that question again using a power? I see one hand. Just one hand. All right, if you want to go for it. Read the what power function just out loud. Using, yeah. What power does B need to be? You basically need to reread this thing.
What power to, oh wait, go down. A B to what power is Y, X, Y.
That's one of those. Yes, I'm going to rewrite what Fiona's writing. B to what power? B to what power? We don't know what that power is y. But we do know the answer. The answer was x, right? So b is to the power of x, exactly. So if I come back here, this is really b to the power of x is equal to y. This formula is in all textbooks. But what's really happening behind the scenes is this is just a what power function. But knowing this form will help us with example 9. So I'm going to call the answer here box. 81 to what power, this box, is 1/27th. I'm going to rewrite this in exponential form. 81 to what power gives me 1/27. I just rewrote this in exponential form. I guess if we were being very technical, we could be maybe using an x. You see it now already?
Sure. Yes,
Or
maybe.
question? Go for it, yeah.
If you do like the thing where you like take out 9 and like you do 9 squared.
Even better because 9 doesn't go into 27. What does go into 81 and 27? 3. So everyone write this down as well. This is 3 to what power then? 3 to the power of what, Fiona? So 3 to the power of 3 is 27, so it's 3 to the power of, loud and proud? 4, yes. You seem like hesitant. 4, and I still have that box, is equal to, and I need to rewrite this right-hand side as well, Fiona.
It could be 3 to the negative 3.
There it is, 3 to the negative 3. And if I treat that box as an x, I can actually solve that. It's 4x is equal to negative 3. So I'm going to call this box x now because it's a little bit easier to solve with an x. So very similar to what we were doing in our homework from last unit, we now set these equal to each other. I have a 3 and I have a 3. If I have the same base, set the exponents equal to each other. 4x is equal to negative 3. 4x is equal to negative 3. Solving for x gives me easy XP here, quiet raised hand. X is therefore equal to Chris or Gio, one of you two. Chris, Gio, one of you solve this. Divide both sides by 4. You get x is equal to, don't give them the answer. Careful, the other way around. There it is, negative 3 over 4. And that is our answer. Our box, we turn our box into x. So this x right here, this is negative 3/4. So one technique is to rewrite it in exponential form and then solve it like we were doing in Unit 14. Our unit, I don't know why I'm saying 14. Our last unit, Unit 7, when we were just doing exponentials. And that's all I have for you guys today. This is the hardest type of problem. I know that last one was confusing. But in general, where do you guys put yourself? And this is going to be on a scale of 1 to 4. In terms of this standard, understanding that logarithms are the inverse of exponents, where do you put yourself? And I am expecting really low numbers. 3, 3. All right, I'm expecting these numbers to go up.
Well, I understood that.
Okay? Yeah, I mean, if you understood this entire lesson, you're pretty close to being done, because if we look at our unit guide, we have 8-1 and 8-2. Those are the only two lessons where you actually learn this standard, and then you actually get assessed on that standard on, is that going to be Friday? No, on Thursday. And then you're going to assess on a scale of 1 to 4, how well do you know this standard? If you put in a 4, that's going to be blue, 3 is yellow, or 3 is green, 2 is yellow, 1 is red, and those are the only possible options that you have. And of course, you're still doing the same thing on Khan Academy. If you're getting your percent, if you got like 75%, you're putting 75, that'll color code, do the same thing as last time. All right, are there any questions for this lesson? Nope. All right, that concludes the lesson.